3.3 actually does get a lot more questions. You're going to see some of these that have the yellow background. Again, those things have been copied directly from your textbook. And so this 3 has actually those same terms that we've just finished up with. Negation is that tilde, which means not. Conjunction is like and, but it doesn't have the crossbar in the A. And a disjunction translates to or, and it's like a V. But we have critical things to say here. If you've got a conjunction, and is only true when they're both true. Only true if they are both true. So when it says and, the first part has to be true and the second part has to be true, or you mark it false. Don't stop and consider and debate too long on one part of the other of it. If they're not both true, then mark it false, okay? And is only true if they're both true. The flip side of that, or. An or is only false when they are both false. And is only true if they're both true. Or is only false if they are both false. You are going to hear me say that several times, but it's critical you get that. Write that down somewhere. That's going to be a key to doing your homework. So if we have not, it's going to have the opposite truth value. Now, this is the first lesson where we start to consider whether or not things are true or false. Rather than spend a great deal of time on what the statement itself says, though, for most of you, it's going to be much easier just to follow the rules. Whatever the original statement is, once you put that not in front of it, it has the opposite truth value. So if it was true, it's now false. If it was false, it's now true. So if statement P says, Dallas is the capital of Texas, that is a false statement. So as soon as we say not, it becomes true. Dallas is not the capital of Texas. True. All right, now let's look at the conjunction. Now remember, it's only true if they're both true. So when you have the word and, they must both be true for it to be true. Statement, Atlanta's in Georgia. True. 2 is less than 8. True. Now when we put that together, Atlanta is in Georgia and 2 is less than 8. They are both true, so the entire statement is true. It may seem unrelated, both true, the entire statement is true. Now you can see the next 3 statements on here. One of them is negated, or both of them are negated. So if we say Atlanta is in Georgia, true. 2 is not less than 8, that's false. Then the fact that we've put and in between them, the entire thing's false. Okay, I'm not going to read word for word there. You can pause it and read those sentences if you want to. They are examples. Key thing, I cannot say this enough. An and is only true if they are both true. Now, an or is only false when they are both false. So here we have a couple of statements. A square has 4 sides, true. A triangle has 3 sides, true. If you put an or in between them, they are both true, so it's still true. If you negate one of them, like the next 2 statements do, you end up with 1 true statement and then 1 false statement. But as long as one of them is true, it's true. Looking at the last sentence, a square does not have 4 sides, or a triangle does not have 3 sides. Now both of those statements are false, so the entire thing is false. And is only true if they are both true. An or is only false if they are both false. You're going to have to create some truth tables, and you actually don't even need the statements to create the tables. Suppose you have 2 statements, P and Q. What we have outlined here is the only possibilities. Either P and Q are both true, P is true and Q are false, P is false, and Q is true, or they're both false. Those are the only things going on. So what you're going to do to create a truth table is whatever your original statements are, you want to list all the possible values of them. Don't think about what they are, just list. We know that whatever the statement is, it could be true or it could be false. Now, we always start off, just to help ourselves be organized, by taking the first statement and listing it true half the time and then false half the time. And then alternate on the others so that we get consistent. That keeps you from getting confused, particularly if you get 3 statements going. So here, if you are going to make a truth table, this statement down here, even though we don't have real sentences to go with it, it says not, parentheses, P and Q. What you want to do then is you want to create a truth table by taking your original statements. The original statements we have are P, Q. And I'm going to put those here, P, Q. Now, I'm going to go ahead and fill those in. Just like we said before, the first one will be true half the time, and then false half the time. And then we take this one and we're going to split that up for Q. So it can either be true, false, true, or false. Those are my only possibilities. It says add one component at a time until you have the full statement. So the next part of this statement is this P and Q. Now let's just consider what we've said on the previous thing, and I've repeated it several times. This is an and. An and is only true if they are both true. So only here and here do we have both statements true. In all the other cases, that part would have to be false. And you don't need to know what the statements are to know that this is the case. My last column then, I need to add another column to take care of this last component that has the not. So I have a not that I'm going to put in front of, oh, don't know why that happened, but P and Q. If that is not, a not, and we said this earlier, has the opposite truth value of the original statement. So if I put a not in front of that P and Q, I simply need to say, oh, well, if this one is true, the next one is false. And then vice versa. The only place it was true is if they were both true, and then the moment I stuck a not in front of that, that became false. And that's how I figure out the truth table, even without the statements. Now, very often what you're going to do is want to have a truth table ready for 2 statements, and then you can have a truth table ready for 3 statements, and then you can determine which of the cases actually applies, depending on what your statements are. This is a sample of a truth table that has 2 items with an and. You know, they could put different connectors in there. And it's a little bit crazy writing on it, but what we've got, first of all, is I see 3 original statements. I have P, Q, and R. Those are the original statements. So right now, I'm going to fill out all the possibilities for P, Q, and R. I'm going to take 3 of these to be true, and then 3 of them to be false for my first one. Oh, it should have been 4 and 4. I knew it should be half of it, but because if you watch, just what I'm filling out here is all the possibilities for P, Q, and R if you have 3 statements. And that would be the same no matter what the connectors are. When we do this, then I could have, in this next, out of these truths, Q could be true half the time and false half the time. And then the same thing could happen again. So I get true, true, and false, false. All right, now for R, I'm going to alternate true, false, true, false, true, false, true, false. So again, what we have now is just all the possibilities of the truth value of the original statements. I don't know what these statements mean, so I don't know which one is actually applying to my case, but this is the possibilities. So now you want to look at what we need to negate. If you want to look up there, my inside, starting on the inside here, I have a Q column and I have an R column, but I don't have a not R column yet. So that's the very next thing I'm going to put is not R. All I have to know here is that it's the opposite truth value of what the R column is. Right, so now I want to build, you constantly you just add one more thing until you get the whole thing built. I need to do this parentheses Q and not R. Now there's a note over to the side, and this is really where it starts to apply. It says look at the columns only, don't travel across the row. So right this minute I am looking at this column that says Q, and I'm looking at this column that says R. And I'm going to base my decision on what to put in this Q and not R on those two columns. And is only true if they are both true. So looking at those two columns, I have a true, false. That means this one is false. Then in the next row, I have true, true. Aha, I can use a true then. And is only true if they're both true. False, false is going to give me false. False, true gives me false. True, false. True, true. So again, I haven't hit one where they're both true. And on an and, it is true if they are both true. False, false gives me false. False, true gives me false. I'm simply using that one rule. And is only true if they are both true. Okay, now to move outside of this, I'm going to have a connector of an or, but I'm going to have to connect that to a not P, and I don't have a not P column yet. So I'm going to create a not P column. Now, for this column, again, I only want to base what that is on the one column I want to look at. So I'm not looking at these columns I had marked just a moment ago. To get this one, I am only looking at this column, P. Looking at this column, I know that not P changes the truth value. So everything in the first column, I need to now have the opposite of that written in my not P column. So that means it's going to be. Okay, that finishes up what I need with this first P column, because the next thing I need to look at is actually putting those together. I need to look at the not P column. So that means I'm going to look at the one I just created here. The other column I need to look at is the Q and not R column, which is this one here that's right in front of not P. So those are my two columns I'm looking at. Those are the only two I'm looking at. The connector is an or. An or is only false if they are both false. An or is only false if they are both false. So here, these two that I'm looking at are false. This one has to be false. Again, if they are both false, it's a false. Otherwise, put true. So even without, I know this seems just incredibly crazy, but without knowing what the sentences mean, we can create a truth table. Then if you had sentences and you can interpret what is true or false from your original sentences, then you would be able to determine which of the original cases you had going from these first three columns. And if you knew what the original cases were, then you would be able to determine what the final outcome is. So again, this is a truth table for this statement. But if you had three original statements, then the first three columns of your truth table would definitely look like this. If you have two original statements, the first two columns definitely look like this one. It's the connectives, the ands, the ors, the nots that dictate what the last columns are. You do have a couple of word problems on here. So on this one, we will ultimately figure out what's true or false because we're going to have to apply our case. We can initially look at each one of these statements and simply determine are they individually true or false. So P says prices peaked in 2005. So we'll go over to a graph and look at this peak value of our graph, which we can see right here at this high point. And so since that is the peak value of the graph, we can see that that happened in the year 2000. So that statement is false. Prices remained steady from 1990 through 1995. So we want to look from 90 to 95, but I can see that this is headed uphill. So that statement is also false. Prices were more than $3 per gallon in 2005. So I want to look at 2005, and I can see here the price per gallon falls beneath this $3 line that's going across. So that third statement is false as well. Now, when we start to look at this next part, write the symbolic statement. We've got parentheses, P and Q, close parentheses, or R in words. We could go back up and look at those statements, and then I'm not going to write them all out here, but you would have a multiple choice you could choose, and you're looking for something that would essentially say, prices peaked in 2005 and remained steady from 1990 through 1995. Or prices were more than $3 per gallon in 2005. The last sentence says, use the information given by the graph to determine the truth value of the statement. That truth value will actually be based on the same logic that we were using before, where we apply the rules. We know that P is false. We know that Q is false. And is only true if they are both true. Since here they are not both true, we know that this original part is false. Now R was also a false statement. And so as we look at the connective that puts those together, we are actually saying that we have two false statements connected by an or. An or is only false if they are both false. So here they are both false. Therefore, the entire statement is false. That finishes us up. Follow the rules.